Okay, welcome everyone, and hopefully we'll get a few more come. This actually is the first regular webinar of the class. Last night we did an orientation, which is kind of about the class instead of actually doing statistics. So today the idea is to do statistics. And we're going to be covering chapter 1 and chapter 2. Some weeks we cover 2 chapters, the rest of the weeks we cover 1 chapter. Mostly because some chapters are harder than others, and people almost never complain about chapter 1 and 2. There's a lot of vocabulary in it, but there's not a lot of difficult to understand kind of stuff. But I want to give you a warning. Next week we only cover 1 chapter. Does that mean you should feel like, oh, it'll be easy? No, that's probably the hardest chapter of the entire book for most people. So just let you know that covering 2 chapters does not make things easy. And it does not make things hard. It's kind of the opposite. So why don't I share my desktop and talk about what we're going to be looking at.
No, come here.
Okay, so let me tell you the plan for the webinar. I'll start out, as I always will, with Q&A. So any questions you might have, great time to ask. Could be about anything in the class or anything else. And then we're going to get into the beginnings. So the beginnings of statistics, the first thing you typically do is think about, well, I want to collect some data. How am I going to grab the data? Who am I going to ask? Okay, if I want a sample of the whole world, I can't ask everyone. So what's a good strategy so that you get good representative data? And we'll be talking about some sampling techniques that will help us figure out what kind of processes you want to do so that you can have representative data, and then you can look at it and say, yeah, this is probably what the population is doing. Okay, because you can't know the whole population, but you can get a good guess. And that's what this is. And it's all about trying to prevent bias. Because if you have a lot of bias, then you have pretty worthless results. But if you have no bias, then you have very good results typically. Okay, then I know this is the name of the course, statistics. But statistics has a meaning, and it's all the numbers that you use to grab that quantitative data and talk about it. So some of them you already know. We have fancier words for it, but like average. I think everyone knows the word average. We use the word mean in statistics, but it's the same thing. Or the maximum or the minimum. So those are some, but there's a whole lot of others too. And we're going to talk about a bunch. Then what we're going to do is we're going to look at charts. And you've all seen some charts, okay? Not in this class because you haven't seen anything in this class, but you've all seen charts. You've all seen a pie chart in your life, I'm sure. You've all seen a bar chart, a histogram, and some others. And I'm going to be showing you some that are a little bit more that you may not have seen, especially if you're not just out of high school. I don't know if you all know, but the new high school math has a lot more statistics than the old high school math. So if you're 18 years old, you've seen a lot of this class actually. So it might be easier for you. Okay, if you're 30 years old, you've seen almost none of it. Okay, at least in high school. And that's kind of how it is. So some of these charts you might have seen. Then we're going to look at the Z-score. The Z-score is it's a special statistic, but it's a really important one because it tells you how unusual something is. And that tends to be used a lot. So you probably heard the word outlier before. And the idea is the Z-score is one way of saying what an outlier is. And we'll talk about that in a bit. And then I want to mention variables. So again, there's all these statistics, you know, the mean and the average and then all kinds of other statistics. And we're going to have letters to write down what they are. So you don't have to write the whole word, okay? And that's standard in statistics. So I want you to get used to those letters, which we'll be using the entire course. So, you know, pay attention. And I'll let you know, some of them are in Greek. So, you know, it's not because I like Greece. It's just because that's the way it is in statistics. We use a lot of Greek letters, and some are English letters, okay? But that is the plan today. And again, this is the first regular webinar of the quarter, okay? We had our last night's orientation webinar, but that was just about the class. It wasn't about statistics. So it's the first one that really is about statistics. I want to mention one more thing, is that if you have not found partners, especially, you know, best to be 3 in your group for the project, you want to do that. I noticed a lot of you posted, which was great, saying I'm looking for partners. Here's the thing, there were like 4 other posts saying I'm looking for partners. It would have been even better had you just replied to one of them and said, hey, let's be partners. And then you have your partner. Unless for some reason you like those people, but I doubt most of you probably don't even know each other yet. So, so what I recommend doing is answering someone else's post saying, I want to be, let's be your, you know, I want to be your partner. And then you have your partners. Okay, and if 2 people answer, you're done. And then you have your partnership. And then you can exchange information, however you want to communicate and all that. So let me open it up. Are there any questions? Any questions for any of y'all? There's not a big group. Maybe lunchtime doesn't work well. We'll see how evening works next week. But next week will be an evening webinar, I believe, Monday evening. I can make them all evening if we want. Any questions about anything in the class? But this is a great time to ask. Okay, if there's no questions, I want to get to statistics, and I like to bring in current events or examples of current stuff if I can. This won't be an event, it's going to be something that I just looked at this morning. And I think I asked you last night, you know, those who logged in, where you're from, but I'm not going to remember who's from where at the very beginning. But I am going to look at the Tahoe Daily Tribune. So if you're from Tahoe, you probably know what this is. It's the kind of one of the big news sources in Tahoe. And if I scroll down a bit, they have a poll. Okay, and the poll says, what is your favorite part of the spring shoulder season in Tahoe? Okay, and the choices are less traffic on trails and roads, flowers and vegetation blooming, wildlife coming back, and multiple activity-filled days. Okay, so in fact, I wonder if I can, not we're allowed to vote. Yeah, let's vote. Okay. So we're going to vote by consensus or majority. So pop in your vote. Again, it's not public. Not that I don't think anybody would be embarrassed about how they voted on this, but tell me what you want, and then I'll pick the one that most of us voted. So, all right. That was pretty unanimous here. Less traffic. That seems to be what everybody likes. So I'm going to go to less traffic on trails and roads. And let's vote on it. All right. Well, let me look at this. View results. There we go. Okay, so here's the results. They had 61 voters. And less traffic on trails and roads is definitely the most common vote. Okay, and notice that, you know, the majority. Okay, and by the way, the definition of majority, that's important for this class, by the way. Who knows what majority means? So what's majority mean? Hopefully you know that word. You pop in the chat. Yeah, more than half, more than 50%. Okay. And that does not mean at least 51%. Because 50.5% is more than 50%. So just a note about majority. That's very important. You know, it's everything above 50%, and that doesn't start at 51%. Okay, so notice, look at this, less traffic on trails and roads, which is what you guys voted for. 54% of the votes. Okay, so can we say that for, you know, this people in Tahoe, over half, okay, 54%, think that less traffic on trails and roads is the favorite part of the spring season, okay, the shoulder season in Tahoe. Can we say that? What do you think? He is. Okay. Yeah. So here's the thing. It's the people, and it's not even all the people who read the Tribune. It's the people who read the Tribune and answered the survey. Okay. So yeah, even if it was all the people who read the Tribune, that'd be better, but we don't even have that. Okay. So here's the problem. The problem is that we don't have everyone. Could we get a survey of everyone for this?
Yeah.
One more guess? No.
No.
No. How would you do it? Do you really think you could find every single person in Tahoe and make them answer your question? It's not
Possible.
Yeah, it's never going to happen. Got it?
Yeah.
Okay, so this is a case. This is a case where you cannot get the whole population. Okay, and by the way, and this comes from our Constitution, by the way, Constitution of the United States of America, is that to get everyone, who knows what that's called? What's the word for that?
Voting?
What's that? Here?
Consensus?
You get the idea, but you're saying it wrong. It's not the consensus, but census.
Oh, right.
Census. Census. Consensus means everyone agrees. Census means you told everyone. Yeah, so that's called a census, which you can never get. Okay, and when it comes to things like the population of all of Tahoe, or even worse, if it was all of America, forget it. Okay, or let's say you work for the Forest Service up here, and you wanted to find out what's the average height of pine trees in the Tahoe Basin. Never going to happen. Okay. Okay, and it's not that there's some trees that won't answer the question. It's not about that. There's just too many trees. Got it? So most of the time in the real world, you cannot get all of the data for the entire population. So what you have to do is go to a plan B. And plan B is what this course is all about. And that is you take a survey. Okay, you take a survey. You don't get everyone, you get some. And very important is you want to try to get a survey that is a best representation of the entire population. Because you can't get the whole population, but you want to get the best representation. Okay, you want to avoid bias.
If Zelda's on Amazon, should we
Any
look
questions on that?
if we should get her a new one?
Yeah.
I think I'm going to mute you. Okay, but by the way, if you want to say something, but kind of stay on mute, especially if you have background noise. But you can always unmute yourself. So anyhow, let me give you my favorite example, because it was what if I wanted to find out the average height of students in California? Okay, so what if I considered the first class I ever taught? Sound good? Looked at their average height. Do you think that's going to give you a good estimate of the average height of Californians?
No.
Okay, so the average height, by the way, around 6'11". And I'm sure none of you expected that. I could have put that in my in my three truths and untruths, and everyone would have thought that was false. But no, that's true. And you could probably guess. First class I ever taught. It was at UCLA.
Basketball team.
It was a basketball team, yeah. Yeah, and they all took my pre-calculus class. And that would be like an incredibly horribly biased study to look at your class that happens to be the basketball team and see if that's a good average, for the students in California. It would be terrible. So what you want to do is you want to see if you can find a representative sample, and you want to conduct it in a way that prevents as much bias as possible. So some of the bias on this poll for the Tahoe Tribune poll that we just did, one is called voluntary response bias. Let me put that in the chat box too so you can see it, but it's called voluntary response bias. It's a real problem. And it is what it sounds like, is that it's biased because people volunteer to take the survey. And if people who tend to volunteer are different than the general public, then you have a very bad bias. Okay. And again, I don't know for sure whether the people who volunteer to take this Tahoe Tribune survey tend to be biased or not, tend to, be more interested in traffic, for example, than those who, don't even bother looking online and, filling out a Tahoe Tribune survey. Okay, I really don't know if, how bad the volunteer response bias, but it definitely has potential because this is definitely a volunteer response. Let me give you an example where volunteer response bias was very bad and everyone heard about it in the country. And that happened about 5.5 years ago, a little more than 5.5 years ago, almost maybe 5 3/4 years ago. What was a big survey, if you can think back, 5 3/4 years ago?
Presidential poll.
Yeah, presidential poll. And if you looked at all the polls, who did they say was going to win the election?
Hillary Clinton.
Hillary Clinton. Okay, and were they right?
No.
Okay. If you think so, then I don't know where the hell you've been. Okay, they were wrong on that one. Okay, and that was a classic example of volunteer response bias because Trump voters tend to be the type of people that would not answer a survey when called, whereas Clinton voters were much more likely to answer a survey. Okay, and I'm sure of it, maybe I'm wrong, but I'm sure of it, that all of you have declined to answer a survey before. Some of you without even knowing it, like you get, you get that old, telephone call from some number that you've never heard of before, and you're like not going to answer it, right? Okay, and that could be someone conducting a survey, and they're going to end up only with the people who answer the phone. Okay, so there's some bad volunteer response bias on that. Okay, so you do what you can, if you can, to get rid of volunteer response bias. Any questions on that idea? Okay, let me tell you about some of the techniques to conduct a pretty good survey. Okay, the first thing is, here's a technique that conducts a terrible survey. And what they did here is called convenience sampling. And it is what it sounds like. You just grab whoever happens to answer. You don't do anything to, make sure that you have a good representative sample. Just do whatever's convenient. So let me go here and talk about the sampling. Okay. So the different sampling are, the letters are interesting here, which they shouldn't be, but that's okay. Our convenience sampling is one. And that means grab whoever answers your question, whatever's easier. So collect the easiest way. Okay, do you think that is a good method of doing things you know, if you're going to be doing some scientific research? No, it's terrible. It's terrible, but it's done a lot. I'll let you know that it's done a lot. So you should always be looking at how did they do their sampling, and did they use convenience sampling? And if so, you should be very wary about whether to trust what they are saying about their survey. Okay, because convenience sampling is very poorly done, and it's done all the time. Okay, it's awful. Okay, so convenience sampling is one. One thing I want to mention since up here is statistics versus parameter. If you look at the entire population and take the average, then we call that a parameter. So a parameter means that you grab the entire population and it represents the whole population instead of a sample. Whereas if you took the average for a sample, that would be a statistic. Okay, and they're different. Okay, we tend to use different letters, but you should definitely know the difference between them. Okay, there is a kind of sampling called random sampling, and that is what it sounds like. Okay, but let's see how you do. Pick a random number, and it won't work so well because we don't have a lot of people here, but I want everyone to pick a number. There's nothing like embarrassing about it. Pick a random number from 1 to 10. And put it in the chat box. Okay, so here's a question. Okay, this is kind of a mean question. I'm looking at your numbers. Okay, did you really pick a random number? No, you didn't. Okay, and I don't know if any of you are in psychology. Any of y'all in psychology?
I am.
Okay, so in psychology, you may learn this, is that humans do not have the ability to pick a random number or do anything random. We just can't do that. It's part of psychology. I'm not the expert in that because I'm not a psychologist or whatever, but I have read about it, and they said that that's true, and they've done lots of studies on it. When I said pick a random number from 1 to 10, I almost never get anyone saying 1 or 10. They feel like that's not random. Okay, it's almost always 2, 3, 4, 6, 7, 8. And let me look at your numbers. Let's see, 7, 4, 2, 8. Yep, there you go. Okay, random numbers don't happen. Okay, so if you wanted to pick a random number, what would you do? Because what you did didn't work. The hint is it's easy. Want to see? Yeah, Siri, or just, hey Siri, pick a random number from 1 to 10. Let's see you guys do that in your phone, and now put it in the chat box, and you will get a random number from 1 to 10. Okay. See if you can do it on your phone. Hopefully you all know how to do it. You can also use, let me grab the calculator, random number generator. I created one too, I'm a coder. So 1 to 10, get a random number. Aha, that too truly is a random number. Okay, your phone will do the same thing. Okay, it's no different really. I can't get into the details of how it does it. It's pretty complex, but it is truly random. Okay, so if you ever need to get a random number, what you do is use a computer or your phone to get a random number. Got it? Okay, and it's pretty easy to do. You don't use, your own ability. Finding random people, you're never going to be able to do that by looking around, because we tend to seek people that look like us, actually, it turns out. Okay, and they've shown that, the psychology people have shown that that's true. Okay, so that's a big deal. That's for random numbers. Imagine let's say you had to pick 100 random people in America. Could you do that? No, you're not going to be able to do it. You just can't do it, because you can't ask a computer, grab me a person in America that's random. Computers can't do that either. Just let you know that. Okay, that can't happen. So a lot of times random is impossible. And that's an example of impossible. Any questions on that? Okay, sometimes it is possible. So for example, if I wanted to pick, let's say 5 random people in our class, could I do that? Okay, or you want to do it?
Yeah.
Yeah, there's 30 people in the class. And all I do is I go to the list of students, which I think I'm not allowed to do on and post on YouTube, so I'm not going to show you, but I can go and give you the list of names of the students in the class. I can just call the first one 1, second one 2, and then I can ask the computer, pick a random number from 1 to 30, then say pick another one from 1 to 30, and then I'll get my 5 people, and that's going to be random people. Does that make sense? So sometimes you can, usually you cannot do a random number. I will let you know on your project, you will not be able to do random numbers, random people. Okay, it's just not possible. Any questions about random sampling? Okay. There's something called simple random sampling. Simple random sampling is random, but even more random. I know that sounds weird, but if you wanted to say get 5 people from the class and you wanted to use simple random sampling, here's what you can't do. You can't say, let's suppose we looked at the class and let's say 15 of them were men and 20 and let's just go with it. Let's say 10 were men and 20 were women. So then let's say you decided, since 10 were men and 20 were women, you want a representative sample. So of those 10, okay, let's say you want to pick 6. You want to pick 6 people, actually, is better. Of those 10, you pick 2 men, you pick 4 women. Then that would not be simple random sampling, but it would be random sampling. So simple random sampling means any group of 5 is just as likely as any other group of 5, which is a little different than any individual is just as likely as any other individual. And when we get into stratified, which is coming in next, that we'll talk about, where you can't do simple random sampling with stratified sampling, but you can do random sampling. So the next is stratified sampling. That was kind of like that men and women kind of thing, or often you do it by, say, race, or sometimes you'll do it by political affiliation, say Democrats, Republicans, and others. Okay, what are the things you might do sampling by in terms of thinking about the groups people are in? There are a lot of others. Thoughts? So what else might you choose? What type of groups would you worry about so that you don't bias against one group? Let's see, all jumping in. Okay, nationality could be good. Okay. Another one that's real common is age. Okay, because you don't want to ask all young people because then you've given up on all the old people or vice versa. Does that make sense? Another is income. So for example, if you were doing the presidential election, income might be important. Okay, all kinds of things. Education is another one where you can stratify by. You can look at those who have a PhD versus with a master's versus with a bachelor's versus just a high school diploma versus nothing. Okay, and then you can look at that. Okay, and it turns out stratified sampling is the most common sampling technique that people use. And there's a step-by-step process for stratified sampling. It's very important. Most of you are going to use stratified sampling on your projects. Some will use cluster, which is next. Okay. Okay, yeah, marital status could be another one. Okay, so there's a lot of different things you stratify by. So step 1 is you decide on the strata. And usually what you want to decide on is you decide on it based on bias. is you want to avoid bias. You want to make sure, for example, if you were looking at height, for example, of Americans, you don't want to only ask men. How come?
Men are taller normally.
Yeah, not all men, but men tend to be taller, right? So if you only ask men, you'd have a big bias on the height, on the tall side. Does that make sense? Okay, so if you were doing height, you'd probably stratify by gender. Okay, and you could do other strata too, but definitely gender would be one of them. So that's the first thing you do is you decide on the strata. In our class, we're going to pretty much stick to one type of strata. Like go for the men and women and just go for it. We're going to just not think about others. In the real world, they do multiple strata. So they'll do men, they'll do nationality, they'll do income, they'll do age, they'll do all kinds of different things. But that's too complicated for elementary stats. So we're gonna stick with one. Okay. Step 2, which has become really easy in the last 30 years. And that is research the percent of each type. The easiest way to do that is ask Google. Okay. So for example, if you were doing a study of Lake Tahoe Community College students and you want to stratify by gender, it'd be very easy to go online and find out what percentage of LTCC are men, what percentage are women, and maybe what percentage are neither. Okay. It's very easy to find that nowadays. In the old days, that was hard, but now it's really easy. Just go online and find it. Any questions on step 2? Okay, step 3 is you multiply the percents by the sample size to establish quotas. So if you were to say you want to do a study of, let's say, 200 Lake Tahoe residents to find out about this whole, Tahoe Tribune, what people like about the spring shoulder season. And let's say you wanted to stratify by income. Then you go and you would find out in the different income categories what percent they have. And let's say that, 30% made less than $35,000 a year. Okay, then you take 30% times 200, and that would be 60. And you're always allowed to use a calculator. And then you make sure that 60 is the exact number of people who make the kind of lower income that you survey. You can't survey fewer, you can't survey more. Okay, so if you've gotten your 60th person and the next person you say, how much do you make? And they say, oh, I make $12,000 a year. Then you say, thank you for your time, and you don't ask them the survey question. Okay, so you just keep asking until you get all the quotas established. Any questions on the idea of stratified sampling? Okay, step 4 is the hardest step, actually. Okay, and that it doesn't look hard on paper, but surveying people takes a lot of work. Step 4 is you do the survey and you make sure that you get all the quotas set. Any questions at all on stratified sampling, the most important of all of them, because it's used the most? There's also something called weighted. I'm not going to get into that, but you do that and you weight it. I'm not going to get into details, but it's done a lot. And it's kind of a way of stratified sampling. Okay, there's another kind of sampling that's done, and that's called cluster sampling. But maybe I'll make this all bigger because I realize that the font might be small. Okay, so cluster sampling. And this is done especially for students. And that is you divide the population into clusters that represent the population. Notice, by the way, really important, it's plural. Not one cluster, but many clusters. And this then, should be then, sample every item in each cluster. So what the obvious clusters? Let's say we want to do Lake Tahoe Community College students. It's really obvious. What's the obvious clusters? of students. Not great. We don't have grades actually at our college. Night classes versus day. No, those aren't. That's just two. That's just splitting into two. These are like, you have to sample every single person. You can't sample every person in the day class. Income, no. It's easy. That's a hint. All right, should I tell you?
What year they're at? or in?
Much easier.
Oh,
Should I tell you? Classes. So you go into maybe 5 different classrooms and you ask the classes. Isn't that easy? If you did it by income, for example, the first thing you'd have to find out what the income is of every student. Good luck. And then let's say, you picked a cluster of people who make between 40 and 43,000. Well, then you'd have to find every person who makes that. You can't do that. But it's really easy to walk into 5 classes and, and do the survey. In fact, if you ask the instructor to survey, everyone's going to answer. Because students will always answer me when I ask my students, hey, here's a paper, fill it out. So that's why at colleges, it's very common to use cluster sampling. Let me give you another one that's real common. And I want to remind you that statistics is not always serving people. Sometimes it's things about the environment, for example. So if you wanted to look at, let's do the pine tree example, the height of pine trees in the basin, then you can just grab a map, put a grid on the map, and then grab some of those grids and walk over to maybe the 6 or 7 grids you looked at that might be an acre each, then measure the height of the trees in those 6 or 7 acres, and then you've got it. Okay, or instead of a grid, sometimes you want to make sure, instead of just randomly pick grid pieces, you might want to make sure you pick some that are kind of a flat area in Tahoe, some that are more of a slanted area, some that are near water, some that are not near water. Okay, so if you were going to do an environmental study, then you would almost always use cluster sampling. Does that make sense? Any questions on that idea? Okay, so cluster sampling is, again, it's easier to use. You do want to make sure that you think about it and make sure that your clusters represent the population. So weak versus strong. We don't really have those words, weak and strong. But to be a statistically accurate or representative is a better word. And that might be what you mean. Is that what you mean? Statistically representative or not representative? Yeah. So we don't call it weak and strong. We talk it representative is the word for strong and what you're thinking of strong. So as I mentioned, for a representative sample, you want to make sure your clusters are representative. So for the Tahoe tree example, you just want to make sure that you have a good proportionate number of locations that are in those ecosystems. Does that make sense? Okay, if you wanted to look at, say, Americans, and you wanted to survey Americans, then you could do that by cluster sampling. And then you're probably going to want to make sure that you have some representative samples, so you don't ask everybody in, let's say you wanted to find out how much people like Biden. Well, you don't want to just go to 5 clusters in Alabama, because they're a very red state and they tend not to like Biden. Okay, and similarly, you don't want to just ask 5 clusters in Oregon, because that's the opposite. It's a very blue state and they're going to be more likely to like Biden. So you want to make sure that the clusters themselves, the clusters that you selected, are representative of the population. Does that make sense? And that's how you get a good, strong cluster. Okay, and you always want to look at that when you read an article. You want to see if you can trust it. That's what you want to look at, is how did they perform their study? Any questions on that? Okay, then comes what's called systematic sampling. And this is done a lot in manufacturing. And let me give you an example because I like it. It's one that I personally did. A student came to me. It was a former student, and it was like 5 years after he was my student. He had a company that manufactured towels for hotels. Okay, sorry if it's not that exciting, but that's what he did. And he wanted to show that his towels were better than the ones made in China. And the way he wanted to do that was he wanted to test them by watching them a whole bunch of times and seeing if they kind of lost their strength. Well, you can't do them all because he'd ruin up all his towels, right? You can't wash all your towels many times. Not to mention it's a lot of work. So what I had him do was what's called systematic sampling. So what he did is he grabbed every 100th towel off the assembly line in his factory. And then he took those towels and he tested them out. And that's called systematic sampling, which means you sample every nth item in the population. Okay, that only works if you literally have a long line or a long list of items. And that could be people, but sometimes you don't have a list of all the people. Okay, but that's why manufacturing works, because literally you can do every 100th one that comes off the line. It works in business too, because you can say, you can look at, say, every 100th customer that walks into your store and survey them or you know, see what they did, whatever it might be. So you could do systematic sampling in business for that reason. Any questions on systematic sampling? Okay, convenience sampling we talked about. Okay, and that is you just do whatever's easy. Okay, and again, you should never do convenience sampling if you care a lot about the results. Okay, you only do that for a fun study that no one cares about. Okay, it's just for advertisement or something. I don't know, for nothing. Okay, so that's convenience sampling. You do what's easy. Any questions at all about the sampling techniques? Okay, this is pretty much most of the techniques. There are some others that are more advanced. How do you come up with what n will be? So what you do is that's actually pretty easy. Is you, let's say in the towel example, let's say, in the month that he's going to be doing this, let's say he made 500,000 towels. Okay, I have no idea, but let's say he made 500,000 towels. And let's say he wanted a sample size of 1,000. So then you take 500,000, divide by 1,000, you get 500. And then n will be a 500. Every 500 towel, and then he'll get the right number of towels. Does that make sense? Yeah, so it's very easy actually. You look at the total population size, divide it by your sample size, that's your n. Okay. Next is to talk about statistics. Okay, and I want to do this. With, let's do a survey. Okay, and the rule is I want you to answer the survey. This is the rule of the class. Anytime I ask you to answer a survey question, you have to answer it. If you feel uncomfortable about answering it, you're allowed to lie, because I don't want to force you into saying something that's personal or something. But if you lie, you have to at least say something reasonable. So if I were to ask you how old you are, don't say 75 million years old. That's not reasonable. So you have to give me something reasonable, but most of the time you're not going to lie because I'm not going to ask anything too personal that you care that much about. So let me ask you, I'm going to ask you this. This isn't about lying or not. Anything you're interested about each other? And it has to, it's called quantitative, means a number. I want a number answer.
Wait, what did you say?
A survey question that you might be interested in. Okay, how many pets? And how many pets have you had in your lifetime? Then we'll get all kinds of good answers. And I want to define pet, otherwise it gets too complicated. So let's call a pet an animal that likes to be pet that you've had. So goldfish are not pets, by the way, they hate getting pet. Cats, dogs, maybe bunnies. They tend to, I think they like getting pet. At least my bunny did once. So put in your chat box how many pets you have had in your lifetime. And again, if you don't know exactly, just guess. In fact, I'm going to put in so we get enough numbers. I'm older, so I probably had more. Oh boy. I haven't had the most. I think I've had 11. But I am older, so most of them aren't alive anymore. Sad. Okay. So what I want to do is I am going to go to the calculator again. And as I mentioned in the webinar, I try to put these in order of how we're using them. Notice I've already used the random number generator. That was first. Now we're going to go to one variable statistics calculator. And it says, type in the values from the data set separated by columns. For example, 2, 4, 5, 8, 11, 2, and then click calculate. I tried to make it easy. So let's do that. I'm going to put your numbers in. So we have 6, 8, 15. Then we had 7, 7, 11. Okay. So we have to decide, is this the whole population or is this a sample? And that's actually a question that doesn't have an exact answer for what I just asked, because it all depends on your perspective. This is the whole population of people who are here on our webinar live. Okay. Or we can think of it as a sample of people that are involved in statistics. Let's call it the population of people live at our webinar. Sound good? So I click population. Most of the time it'll be a sample, by the way. Most of the things you do will be a sample. Then I hit calculate. Okay, so I tried to make this easy. Was that pretty easy? Okay, so now let's read these and let's try to understand what they mean. Okay, and by the way, that was a bit of a pun, what they mean. So let's look at the first one called the mean. Okay, so another word for the mean, which I mentioned at the very beginning, is the average. Okay, and the formula, which you don't need because the calculator will do it for you, but it's such, you know what average is. You add them up and divide by the total. Hopefully you're pretty familiar with the average. So 9, the average number of pets people have in this group is 9. Any questions on that? Or people have had, sorry. Is that clear? Okay, I hope I don't have to describe what it means to say minimum. I hope that's a word y'all know. It's the smallest number. So that means 6 was the smallest number of pets our group has had. Any questions on that? Okay, let me get to the next one. The next one is not obvious. My guess is that most of you have no idea what that means when it just says Q1. Okay. Anyone know what it is? For all of you don't count. Okay, Q1, this is important, is called the first quartile. So I'll also put that in the chat box so you have it written. Okay, now we have a very small data set. It's more useful when you have a bigger data set. What this says is that if you take the values and you list them in order, then basically 25% of the values are going to be less than or equal to 7. Okay. It doesn't work that well with a small sample size. In fact, it's frustrating as can be. It's the most frustrating thing there is to me of all of mathematics. I know that seems weird, and I know a lot of mathematics, by the way. And that is the Statistical Society of America has not agreed upon a definition for the first quartile, a calculation definition. So just use this calculator, that'll work. But I want to let you know if you use the other one, the spreadsheet one, you'll get a different answer. Okay, and if you use a T84 calculator, you get a different answer. That's frustrating can be. Now, if you have a very large data set, they pretty much agree. Small data sets, they don't. So I'm not going to get into the formula because there isn't a formula. Isn't that horrible? Do you see why I'm frustrated? And I've talked to these people in charge and they like, well, you know, they can't agree and we don't want to make waves. So they're not going to tell. They're not going to tell the, Excel people to have to change their calculator. Sorry. So that's the first quartile. And it gives you a good idea of kind of the bottom group. Okay. This next one you've probably seen before, probably in 4th grade or so, something like that, or 5th grade. Median. What does median mean?
Middle,
Yeah, it's the middle. Okay. It's a slightly more complicated than that. If there's an odd number of numbers, what did we have? We had 2, 4, we only had 6. Okay. So there is no middle, it turns out. So it turns out that if you have an even number of numbers, it's the average of the 2 middles. And if it's an odd number of numbers, it's the middle. And that's the median. So that in this case, it was 7.5. And that was because the 2 middle numbers were 7 and 8. And the average of 7 and 8 is 7.5. Okay, so that's important. I will let you know the median is very important, but we don't do it much of it in this class. If you take another course in statistics, and I don't mean another elementary stats class, I mean if you take an advanced class in statistics, you do a lot more focus on the median, whereas elementary stats focuses on the mean. So I'll just let you know in terms of how things are done. That's how most things are done. Okay, Q3, that you might be able to guess. If I asked you 10 minutes ago, you probably have no idea, but you might be able to guess what Q3 might be. Any
the
thoughts?
3rd quartile.
Yep, that's the 3rd quartile. So that means 75% basically are at or below that number. So the 3rd quartile is 11. Okay, and it works better for a larger data set. But basically around 75% are below 11, at or below 11. Okay, again, with small data sets, it's not perfect. Large data sets, it works a lot better. Any questions on that? So the Q1, Q3, and the median, the mean and the minimum and the maximum, here's the maximum, that breaks it up into the 4 groups. The lower 4, 4th, right? So you basically the median cuts it in 2, and then the Q1 and Q3 cut each of those 2 into 2, and you get 4 groups. So that's what's nice about those numbers. Okay, then comes this guy, standard deviation. And I want to let you know, I want to give you a forewarning. It is the most important statistic that you might not have heard of in this class. And we're going to be using it over and over and over and over again in this class. And the standard deviation is a measure of how far the data values tend to be from the mean. So the mean is 9. And if you look at these values, 6, for example, is 3 away from 9. 8 is 1 away from 9. 15 is 6 away from 9. Okay, it's a little more complicated than the average away from 9 it is, but you can think of that way in elementary stats, and I'm going to let you go with it. If you were technically, if you were an average distance from the mean, that's more correct than the average distance. I'm not going to get into details because that's advanced. Okay, so standard deviation gives you an idea of how far the values tend to be from the mean. Okay, it's a measure of the spread. So if the standard deviation is large, then that means the numbers are very spread out. If the standard deviation is small, that means the numbers aren't very spread out. Any questions on that? Okay. The variance, which after today, we're never going to talk about it again, is the square of the standard deviation, and it's not very useful unless you're a mathematician. So we're not touching it. Sound good? IQR. IQR is called the interquartile range. What that measures is the distance between Q1 and Q3. Okay, remember Q1 says, what is that 25th percentile? 25% or below that. Q3 is 25% will be above that. So the IQR is the range of values in between, or in other words, what is the range of the middle half of the values? Any questions on what IQR represents? So if you're most interested in that middle half of the people, in terms of number of pets people have had in their lifetime, then they're spread out by 4 pets. Any questions on that? The sample size. I'm hoping you all know what that means. 6. What was that? Supposed to be an easy question. Yeah.
The total number of samples.
Yeah, not total number of samples, total number of responses. We had 1 sample. Right, we had 1 sample. You guys were the sample. And it's the sample size, which is the total number of responses. Okay, or the number of entries in your sample. Any questions about any of these statistics? Okay, or if you consider this the whole population, any of these parameters. So we call them parameters if you're considering it to be a whole population. You call them statistics if you're considering them to be the a sample. Any questions at all about any of these? Okay, you're responsible for them all. Just let you know that. They're all important. Variance is the least important. That's the one we're not going to do anything with. Standard deviation is the most important. Okay, of the ones that you may not already know. I assume you already know the mean. That's the average. Because in a way, the average is the most important and the standard deviation is the next one, but I hope I don't have to spend much time on what an average is. I'm hoping you got that in elementary school and continued on using it for most of your life. So the formula for the standard deviation is it's a summation from I equals 1 to n of x minus mu quantity squared over n minus 1 all square rooted. Okay.
So we'll just use the calculator.
Exactly. Okay. My job is the formula. Got it? Because
Yeah.
I had to code this sucker.
No problem. Calculator.
Yeah. And if you are a math lover, I need to apologize. You may not like this class that much because I put a lot of the mathematics under the rug. Okay, I hide it. We don't do the heavy mathematics, and there's a lot of heavy mathematics in this, but we don't do it in this class. Okay, what I want you to do is understand what the numbers mean.
Yeah, for sure.
Yeah, the calculator does a good job. When I first taught this class, then you did need to know all the formulas. And anyone know why? Here's a hint, I'm old.
No calculator yet?
Yeah, computers didn't exist. Students didn't even know how to use a calculator. Calculators existed, but most students didn't even know how to use a calculator and they didn't own one. Things were different in the old days, but things are different now. Okay, so we let the calculator do most of the stuff for us.
Sounds good.
Okay, any questions at all in this example? Okay, let me go back to our webinar. Okay, so I have a question, just a fun one. So suppose my goal is to have most of the students pass this class. Sound good? And I don't know if you remember from last night, 70% or higher is a passing grade. C or better is passing. And I graded a 98, 70, 60. Okay, and let's suppose last quarter, the average score was 74%. And I'm gonna erase this for now. And that's all I know. The average score is 74%. Did I reach my goal?
Yes.
Okay, this is a trick question.
Don't have enough information.
The answer is you can't know from this piece of information. Okay, because it's possible, maybe I had one student get, maybe I had a couple students get 100%.
Some people got
And
0.
everyone else in the class got 69%. That's possible. Maybe the average of that might be 74%. Does that make sense? Most of the students got a D, which would be awful. Do you agree?
Yep.
Okay, so if all you know is the mean, the average is the mean, that's not enough to really understand the data. Okay, what you need to also understand is the standard deviation. So if all you knew was the average score of 74%, then that tells you nothing, okay? So let me tell you more. Let's suppose, oops. Let's do this. Let's suppose the standard deviation was 0.02%. Am I satisfied?
Yes.
Yeah, because everyone passed. Just let you know. If the standard deviation is 0.02%, that means that pretty much everyone is within even 0.5% of 74%. Every single student gets a C in the class. Again, you may not be happy with a C, but I want everyone to pass. That's what this says. And I'm very satisfied. Do you see?
Would you just multiply 0.02 times 74 and then you get what the standard deviation is, or no?
Well, no, I just told you the standard deviation is 0.02%.
Oh, okay, so it doesn't, all right.
Yeah. So if I asked you what is the standard deviation, well, I told you it's that percent, 0.02%. Do you see that?
Yeah,
Yeah,
yeah.
So that's just given. Yeah.
Right.
If you wanted the standard deviation, then you get all the grades in the class and you put it in that calculator and you hit standard deviation.
Right, okay.
I mean, you hit the calculator, it'll give you the standard deviation. Okay.
Yep, gotcha.
But on this one, I actually, told you what it was, so you just use it. Does that make sense?
Yep.
Okay. So that's a big deal. Let me give you another example I love. Okay. SAT, which is kind of doesn't happen anymore, but in the old days, okay, there are SAT scores. Okay. I got an 1160 on my SAT. That was my SAT score. My daughter got a 2000 on her SAT score. Who did better?
Your daughter.
Okay, and the hint is another trick question. You have no idea. Why do you have no idea?
You don't know what the max score is?
You don't know the max, you don't know the averages.
Oh,
You don't even, you don't know the max, you don't know the averages, you don't know the standard deviation, you don't know any of the statistics. And obviously, I hope this is obvious for all of you that my daughter and I are different generations, kind of by definition, right? She is my daughter. So she obviously took the SATs a lot later than I did, or a lot closer now than I did. It was still a bunch of years ago. She's 27 now. But you don't know, right? You can't know for sure. Okay. And did my daughter do well on the SAT? Can you tell that? You don't even know if she did well. She could have done horrible. She could have done well. You really don't know. Does that make sense?
She did better than you though, right?
Oh, you don't know that either.
No.
It was a different generation.
Oh, okay.
I'll let you know that when I took it, it was out of 1600. When she took it, it was out of, I think, 2800.
Oh, I see. Okay.
Wasn't even out of the same score. This is just random numbers that don't mean anything if
For
you don't
sure.
have any context. Do you see that?
Yep, absolutely.
Okay, so now let me tell you about my daughter. Okay, and by the way, it's my daughter, so I could be proud. So she took the SAT, and there is something called the Z-score, and this is very important. Okay, the Z-score, the formula is as follows. It's Z is equal to X minus mu over sigma. So I want to mention a few things. Mu, first thing is a Greek letter, and it is a population mean. The way I always like to remember it, who remembers the first, besides myself, who else did you see on the webinar yesterday that was in my house?
Cat.
My cat. And what did she say? You probably didn't hear her. She said, mew, mew. So just remember that. My cat loves mew. And that's the average. It's a population mean. Okay. Sigma, that's how you read this bottom letter, is the population standard deviation. Got it? Okay, we're going to be using those letters for the entire rest of this course. You need to know them. Got it? You should know how to say them. You should know how to write them. You should know how to read them because they're the biggies. So mu kind of looks like a U with a little extra tag on the left, on the bottom. Sigma kind of looks like an O, but it's got a hat on it. And again, mu is the population mean, sigma is the population standard deviation. X is the value that you're looking at. So in this case, my daughter's value was 2,000. Got it? Any questions on that so far? Okay, so suppose my daughter got a 2,000 score on her SAT. And the mean SAT was 1650. And the standard deviation was 115. Did she do well? How well? Any questions on the question? Okay, so the idea here is 1650 was the mean. If you go a standard deviation up, that's kind of the average away from the mean that people are. And if you add that, that would be what, 1,765. So she definitely, did pretty good, right? But how well did she do? Okay. So the idea is to go find the z-score. So we're going to find the z-score, and I'm going to do this one. There's a z-score calculator, but this is simple enough that hopefully you can all do this. So we can say z is equal to x, which is 2,000, minus mu, which is 1650, divided by 115. Any questions at all? Any questions at all on putting these numbers into the z-score formula? This is our first mathy looking thing we're doing in the class. Any questions? Okay. Again, you're always allowed a calculator, so I can just grab it. And we can say 2,000. Need some parentheses in the numerator. That's really important, by the way. And then star is times in Google. Oh, sorry, divided by is what we want. And we get a little more than 3. So we'll just call that 3. Okay, so that is 3 full standard deviations above the mean. Did she do well? Did she do very
Yes.
well, or just kind of a little above average? What do you think?
She's an extreme outlier.
What university do you think she might have gone to? And by the way, I'm a teacher. I don't have a huge amount of money. I didn't want to like spend hundreds of thousands of dollars on her education because that would have could have taken me down. So I wanted to go public. Where do you think she went?
UCLA,
Better, that's where I went.
Berkeley.
Berkeley, yeah, she went to Cal. So she went to Cal and she got in, okay, because Cal's looking for that. Cal's looking for top students. So again, what's nice is if I just said her Z-score was 3 without giving you any of this other information, you know she did really well. So all you need is a Z-score and you got the idea of how well someone did. Does that make sense?
Yep.
Okay, let me give you another example. I'm going to say this orally. Let's suppose you're working as a nurse and delivering babies, and a baby was just born, and its Z-score in weight was -2.1. What does that tell you?
Maybe it's premature.
Yeah, that means that baby might need some very special attention medically, because that baby is an outlier on the low side of births, of weight. And by a really low birth rate is dangerous. Again, so if you're a nurse, you would know that, or doctor. That's not my expertise, but it is my brother's expertise. He's a delivery doctor. That's what he does for a living. So if you know the Z-score, that's all you have to know. And then you know whether this is something, that you have to worry about. What if the Z-score was 0.3?
Healthy.
Yeah, normal. I would call it just healthy. It might not be healthy, but at least weight-wise, it's a normal weight.
Healthy
Okay.
weight.
Yeah, healthy weight. Yeah. So at least weight-wise, nothing to worry about. Normal, good old-fashioned weight. Okay. What if the Z-score was 3.1?
Fat baby.
C-section. You know
Oh,
what a C-section is?
yeah.
Yeah, that baby is way too big, and they're gonna rip that thing out of the mother's belly or uterus, because no way is she gonna be able to pop the baby out without getting really badly harmed. So if you're doing medicine, very important to understand these Z-scores, because it tells you how to react. Okay, is this something unusual? Is it unusual on the low side or high side? Low side is negative, high side is positive. Okay, or is it normal? Any questions on Z-score ideas? Okay, and just some definitions, very important. So again, the Z-score is how many standard deviations above the mean the value is. And here's a very important definition. In fact, let me put that guy in red. If the absolute value of Z is greater than 2, then we call the value an outlier. You've heard the word, but you probably didn't know the math definition. This is the math definition. Okay. There's actually 2 definitions. This is one we're going to use in our class. So if the absolute value of Z is greater than 2, then we call it an outlier. If the absolute value of Z is greater than 3, we call it an extreme outlier. So if I ask you to find the outliers, what you do is you find the Z-scores for the value, and anything that's less than -2 or greater than 2 is an outlier. Any questions on that? Easy enough? Okay, and it's really important. A lot of times you're interested in the outliers. It doesn't always mean bad things. Sometimes it's good things. Okay, like the SAT score. You have an SAT with a Z-score of 3. That means you're happy, right? You did awesome. Okay. Any questions on that idea? Is that clear? Okay, very important. I want to talk about some charts. That's the last bit today, is to talk about charts. And let me go to the statistics spreadsheet. And this is a spreadsheet where you can put in numbers and it'll give you some charts. So maybe we'll pop in, I don't know, I'll just put in some numbers. And what you want to do, by the way, if you're doing for your own numbers, the first thing is just highlight them, hit the backspace, and that erases everything in there. Okay, after you made your own copy. If you haven't made your own copy, you can't do anything. So you make your own copy first. I showed you last night how to do that. And then let's put in numbers, okay? And let's suppose, I don't know, how about how many hours a week you're going to study for this class? Okay, let's say we had the first person said 15, the next was 20, the next was 32, the next was 4, probably going to fail the class, and then 12, and then 13. I tried to make it easy so the histogram just shows up as it goes. Okay, 15, 18, 21, and 27. Okay, so it's pretty easy to just type in the numbers. And so here's a histogram. So a histogram, just to let you know, is a bar chart. And hopefully you know that these are bars. And it's a special kind of bar chart in which the x-axis corresponds to numbers. So it's not bars with like qualitative data. Qualitative means that it's just word answers. Quantitative means number answers. So it has to be quantitative data. It has to be so that each bar has the same width. So 0 to 7, 7 to 14, 14 to 21. You'll see these have the same width. And it gives you a good idea of the shape of the data. So when I'm looking at this data, I call this unimodal. Any guess on what that means? Unimodal. Because you know what a unicycle is probably.
One mode.
One mode. And the mode is the most frequent. So there's one bar that is definitely the most frequent bar. Does that make sense? This is unimodal. This one happens to be symmetric. So if you look at the left side and the right side, then they're the same. So if you take the middle and think of it as a mirror, you get the left and right are mirror image of each other. So this one's symmetric, it's unimodal. This is what we call, when it's symmetric and unimodal and kind of in this nice shape, we call it normal. That's going to be a big word for this class, by the way. Okay, it's called normal. So this is unimodal, symmetric, this is approximately normal. Okay. And that's how we do it. Okay. On the other hand, if I added some more, let's add in some other numbers. Okay, now it's not now it's unimodal, but it's not symmetric. Do you see that? Do y'all agree?
What does the y-axis represent?
Y-axis is a count of the frequency.
Oh,
It's how many did that.
right.
Throw in some more numbers. Okay, it's no longer unimodal. Now we call it multimodal. It has 3 different modes. It's not symmetric at all. And in fact, we call this one skewed right, because we see that kind of the high points are on the left. And then from there, you go to the right to go down to the low points.
So 4 people said that they would study 0 to 7 hours.
Exactly. Okay. And by the way, I made these numbers up, so it's not like I took a real survey, but you could take a real survey.
Right.
Okay. So this is unimodal, and this is like trimodal. We use some multimodal. It's not symmetric. It's skewed right. Any questions on that? Let's even throw in, and it has an outlier. Because I just put in an outlier, and that's obvious from just looking at it that there's an outlier. Okay, histograms are really good for showing the shape of the distribution. Okay. There are other things you can do. I'm going to get rid of the 91 because that's not very realistic. You can go to stats, you can go to box plot. On your computer, it might yell at you saying that you might get a virus, you won't. This is a box plot, and what this is what's called a 5-point summary. It gives you the 5 essential numbers. It gives you the minimum, the maximum, that's the low and the high. It gives you the median, that's this bar here. and it gives you the first quartile and the third quartile. And it does this with this bar chart picture. Sorry, box plot picture. Sorry about that. It gives what's called a box plot. And then the box, this red area here, is the middle 50% of the group. So box plots are really good for showing the middle 50%. One thing box plots are terrible for is if you present this to a group of people who've never taken statistics, why is this a terrible thing to have?
I still see the histogram.
Oh, you don't see the box plot?
No.
Let me try.
How
Can
did
On the
you
right
get to the
side.
box plot again?
you see it now?
Oh, I see.
Yeah, I made the screen smaller, so it's on the right. Yeah, it should be there though.
How did you get to that again?
I went to stats and I hit box plot.
That looks
Okay.
like a candlestick graph for charting the markets.
There's all kinds of charts.
Yeah, you ever see candlestick charts?
I've seen them, yeah.
Yeah, that's just
But we can't, I'm only gonna do a few.
right.
There's another one that's important called the stem and leaf plot. This works great when you have 2-digit numbers. And you don't have too big a data set. If you had 1 billion, you can't do it because it shows all the numbers. This is the tens, this is the ones. And we can see, for example, the mode really easily was 4, because you see the 444. Okay, where nothing else has triple. So the true mode was 444. The histogram doesn't show the true mode because it only does in brackets. The stem and leaf does the exact. It also shows the shape of the data. This is terrible for number files, like number phobes, people who hate numbers, because it'll scare them off in a presentation. But it's good when you have not a giant data set. This bottom part, by the way, you don't have to worry about it unless you're blind, but I put that in there so that it is accessible to people who don't have vision. So that's why I put that in. And let you know that it may not work on your computer. Your computer may hate the fact that I might throw you a virus at you, which I won't. And that's why I put these links in here. And these are other ways of getting these plots. Just let you know that. Any questions on these plots?
Hey, you said something before about you had to delete everything so that you could use it yesterday. Is that right? We use it ourselves.
When you use it, not me, you have to.
Right. Can you just do that one more time?
Okay, it's really easy. All I do is go highlight the numbers and hit the backspace.
Oh, okay. That's it.
You could delete them one at a time, but it's a whole lot easier
No,
to
yeah,
highlight
yeah.
them on backspace.
Okay. I thought you said something about copy and pasting it or something.
No, nothing fancy, but you're gonna want to do that.
Right.
And now it says no data because I deleted everything.
Right.
Let me undo that because I do want my data. Control Z will do that.
Thank you.
Okay, any questions on these charts? They're very important. Okay, by the way, if it's normal, remember I showed you that picture of normal, then about 68% of the data is going to have a z-score between -1 and 1. About 95% will have a z-score between -2 and 2. And about 99.7% will have a z-score between -3 and 3. Okay. Again, we only have so much time, so if I type everything out, we don't have enough time in the webinar, and I try not to make these too long. We're already getting close to the length I like to go. But we can see a lot of different types of charts. There's some other charts which I'm not showing you because you should already know, like pie chart. You've seen pie charts, hopefully. Okay, and there's a zillion other charts. There's another biggie that will come up later in this class, and that's called a scatter plot. But there are a lot of different charts. And there's a Pareto chart. There's a lot of different charts. A line chart, a time series graph, candlestick. But I can't do them all because we can only do so much. So sorry about that, but it's only one class. But by the way, if you're interested in statistics and the market, for example, and I don't mean grocery market, I mean the NASDAQ or the stock market. I'm very involved in that.
Oh,
I
cool.
made a lot of money on it. So there's and I'll get into that another day because I heard you talk about
I'd love to learn about that.
So that will happen in this class. What I can't tell you, because because I can get sued as to which stock to buy, because then if you end up buying it and then lose money, then you get mad at me and, sue me or whatever. But I can tell you how to look at stocks, and I can tell you what I've done in the past. And I've been in the stock market since before any of you were born. Just
That's
let you know.
awesome.
Although I don't know how old you are, but over 40 years.
Me.
Yeah. I got a present when I was 13 of stock. It was really cool. That got me involved. So it is definitely used in the stock market. Statistics is used in so many places. And that's why I love this, teaching this class, is I don't have to like pretend like it's useful. It is useful.
Yeah, for sure.
And we'll see that. So the next thing I want to do, which is the last thing. Actually, the last thing, let me do the last thing. Secret word is statistic. Don't put an S at the end. Remember, a statistic is a value that you get from a sample. So
The secret word
sample
from,
mean is a statistic. Huh?
oh, sorry, I apologize. The secret word from last night's orientation, was there a way to put that in? I didn't like see both of them, you know what I mean? I saw one for
I
this
think it was
webinar.
in one place and not the other, and I noticed that this morning.
Yeah,
and
it
I
was
changed
only
it.
in one
And it
place.
should be there. It should be easy to find now. Sorry, if you go to modules, pretty soon it'll just be your first page. But I like to spend a day or two having you look at the syllabus. And tomorrow I'll probably make it the modules. You go to the modules, and you'll see orientation secret word quiz.
Okay.
I think it wasn't there, unfortunately. I'm not even sure why, because I copied from last quarter.
I couldn't find it and I was confused.
Yeah, the other place that you can find things, if you go to the syllabus,
Mhm.
and it was there before I put it in, and on the modules.
Yeah.
And you scroll down down here, this will tell you by date when things are due, and this has been here the whole time. Secret word quiz.
Okay.
So
Okay.
that's a way to find things by date on when things are due. The modules are weekly. Does that make sense?
Was that quiz not working last night? I tried it twice last night and I got it wrong twice. I don't know if it was me or it was not working or what.
Drop me an email with the secret word, and then don't say don't say it here, but
No, it worked this morning, but it didn't work last night.
oh really?
Yeah.
Okay, something weird happened.
Yeah.
It might have been a capitalization issue. You might have done capital and not capital.
Or maybe I put a space at the end of the word. Does that?
Yeah, that can matter too. Space might matter. Yeah, try
So
to.
no capitals.
Yeah, no, yeah. Type it exactly as I type it.
Okay.
So here we go. Yeah, don't use capitals, because I'm not the one that codes it. It's not that I'm being mean. I just type in the word and it's supposed to give it to you. And if for some reason it doesn't, but you know it was right, send me an email. Don't
Okay.
post on the Q&A, because then you're posting a secret word. That's an email kind of thing.
Right.
Okay. I want to mention a couple things, and I mentioned a couple of them already, and that is key notation. If you have the sample mean, so that's the average, but for the sample, not for the population, then we have X, and it has a little bar on top. And the way of saying this is X bar. Nice and easy. Okay. It is a pain to get this typed in on a computer, just let you know that. So if you ever need to type it in, it is fine. Like on the discussion forums, it is a real pain. Just type in XBAR and that's fine. I'll take it. Got it?
Mm-hmm.
Okay, because it's actually really hard to, you have to actually use something called LaTeX coding, and I'm not even going to get into that. It's just brutal. So XBAR is the way you just type it in, and I'll be good with that, and hopefully everyone will understand. I usually let X capital BR because it looks better, but even if you didn't, that's fine. This one we did. How do you say this one? Population mean is, the Greek letter is?
Meow. Meow.
Oh, yeah, mu. Mu. It's like meow, it's mu. Yeah.
Meow.
And sample standard deviation, since it starts with an S, we use S. That one's an easy one. So that's a standard deviation of the sample, which turns out to have a slightly different formula than the population. And that's why you had to click it on that app that I wrote. And then who remembers how to pronounce this guy? Population standard deviation?
Sigma.
Sigma, okay? Okay, and again, if you type SIGMA, that's fine. If you type, MU is how you write it. I'll let it happen. Your project, I'd rather you do it correctly, and that you can just use Greek symbols. You could either do it with an equation editor, or you can go to font and do Greek, one or the other. Anyone speak Greek? I've yet to ever have a statistics student speak Greek.
I know. Oh,
You know letters, yeah, but yeah, no one's from Greece. Okay, I've never had a statistics student from Greece. Okay, but anyway, those are the big ones for now. We'll have others later. We're not done, but for today, we're done. And it's 1:30, which is about when we want to be done. As I mentioned, hour and a half-ish, if you remember, is usually how long these webinars go. I don't know if you remember asking, but that's what I said.
I do.
So we're about an hour and a half is about right. And I want to remind you, I'm gonna stop this share. I'm gonna stop the recording, actually. That one is, there it is, stop recording.